In this video, we'll discuss states of matter and the relationship between different states of matter. Substances are held together by a force called the intermolecular force. So the molecules in that substance have a force, a push or a pull, that keeps them together. So when you think about solids, all those molecules are packed tightly. They have a really strong intermolecular force. But when you have a liquid, those molecules are moving past each other. So yes, there's a strong intermolecular force, but it's not as strong as solids. And then with gases, that force is um, is overcome by the energy in that system. And so those molecules fly away from each other, and there's no real force holding them together. Three different types of intermolecular forces are dipole, hydrogen bond, and London dispersion force. The dipole forces occur when you have partially positive and partially negative charges on molecules that lead to an attraction. It's kind of a weak bond. You have the hydrogen bond that's very similar to that, but this happens between hydrogen and oxygen. So water molecules, they form a hydrogen bond, partial positive from the hydrogen, partial negative from the oxygen, and that forms an attraction. Now, the London dispersion force is where a temporary dipole is created. So even though there might not always be a permanent charge, there would be a temporary charge. And that temporary charge would lead to an attraction of one molecule to another. And so when you look at each state of matter, solids have low kinetic energy, high intermolecular force. Liquids have a higher kinetic energy but a lower intermolecular force. And a couple different terms that we use to describe liquids would be viscosity, that's the resistance to flow, vapor pressure, how quickly a liquid evaporates, surface tension, the resistance to penetrate the surface, and then density, the degree of compactness. Well, gases, they have a high kinetic energy, which means the intermolecular force is not strong enough to overcome that kinetic energy. When you compare different characteristics of each state of matter, solids and liquids cannot be compressed, but if you think about it, gas, there's a lot of space between the molecules, so you can compress those. Solids have a definite shape and a definite volume. That neither one of those will change. A liquid has an indefinite shape. If you rotate the container that a liquid's in, the shape will change, but the volume will not. So it's a definite volume, where gases have an indefinite shape and an indefinite volume. Now, when you're talking about changing from a solid to a liquid to a gas or any variation of that, it's called a phase change. And this is a phase change diagram. So if you have a solid, but if you increase the energy, that solid, depending on the substance, can melt. And then when it melts, it's a liquid. And then if you keep increasing the energy, then the liquid will become a gas, so it vaporizes. Now, during the process of melting, notice our temperature increases with the solid until you get to the freezing point or the melting point. And when that happens, during the process of melting, that temperature stays constant at the melting point. Then when all of those particles have melted, then it's a liquid and the temperature increases until you get to the boiling point, and then the same thing happens. The temperature is consistent until all those particles are in the gas state. But if you're going the opposite direction, it's also true. So if you're decreasing the energy, if you have a gas, the temperature decreases until you get to your boiling point, and then it starts to condense. And then once it condenses, all of those particles are liquid. Temperature decreases until it freezes. During the freezing process, the temperature remains constant. Once all of those are a solid, then the temperature will start to decrease again.